Hello, in this video we are going to see the week 4 practice assignment solution.
So our first question is, what is the correlation coefficient between temperature measured in Celsius and temperature measured in Fahrenheit? So what is the correlation coefficient? So correlation coefficient measures the strength of the linear relationship between two variables. So our first variable here is temperature measured in Celsius and temperature measured in Fahrenheit. So we have to find the correlation coefficient between temperature measured in Celsius and temperature measured in Fahrenheit. So as we know that the relation between temperature measured in Celsius and temperature measured in Fahrenheit is given by F is equal to 9 by 5 times C plus 32. So this is a linear equation. So if we plot the graph of this equation, this is our x-axis, this is our y-axis. Let's plot this is, let's say it is temperature in Celsius and this is Fahrenheit. This is temperature in Fahrenheit. We'll start from 0. So this graph will look something like this, and where this 32 will be the y-intercept, this is 32 degree Fahrenheit, and 9 by 5 will be the slope of the line, this line. So as you can see from the graph, as temperature in Celsius increasing, temperature in temperature in Fahrenheit also increasing, and all the points are lying on this line, falling on this line. So this is a perfect linear relationship, and the correlation will be equal to R is equal to 1 in this case. So R is equal to 1 is the correct answer, where R is your correlation coefficient. This is Pearson correlation coefficient.
So let's move to our next question. The question is, calculate the correlation coefficient between marks obtained by a set of 10 students in their class 10th and class 12th exam. So we have presented the marks obtained by 10 students in their class 10th and class 12th in this table, where X represents the marks obtained by students in their class 12th and Y represents the marks obtained by the students in X represents the marks obtained by students in the class 10th and Y represents the marks obtained by students in class 12th. So let us say Xi represents the marks obtained by students. Let Xi represents the marks obtained by students in class 10th and Yi represents the marks obtained by students in class 12th. So this is 10th and this is 12th. This is 12th, where I is varying from 1 to 10. Now we have to find the correlation coefficient. So what is the formula for correlation coefficient? The correlation coefficient R is equal to covariance of x comma y divided by product of standard deviation of x and standard deviation of y. So in order to find the correlation coefficient, we need to find the covariance between xy and the standard deviation of x and standard deviation of y. Let's start with our standard deviation first. So what is the formula for standard deviation? So standard deviation of x will be equal to under root of sum over xi minus x bar whole square, where I is varying from 1 to 10 divided by 10, and standard deviation of y is equal to under root of sum over yi minus y bar whole square divided by 10, where I is varying from 1 to 10. So in order to find the standard deviation, we need to find the mean for the marks obtained by students in class 10th and marks obtained by students in class 12th. So we need to find the marks obtained by students in the class 10th and 12th. Let's calculate that. So this is our x, this is our y. Let's calculate the mean marks for the students that they obtain in class 10th and class 12th. So what is the formula for mean? So as we know that mean is given by x bar is equal to sum over xi, where I is varying from 1 to 10 divided by 10, and similarly y bar is equal to sum over yi, where I is varying from 1 to 10 divided by 10. So let's calculate the sum. So the sum will be equal to 4619, and if you add up all those marks for the students that they obtain in class 12th, it will be equal to 3740. So mean marks obtained by students in the class 10th is equal to 4619 divided by 10, that is equal to 461.9, and the mean marks obtained by students in their class 12th is 3740 divided by 10, that is 374. Now let's calculate the deviation of the marks obtained by students in their class 10th from the mean marks obtained by students in their class 10th. Similarly, for find out the deviation of marks from mean marks that they obtained in class 12th. So let's calculate. So this is xi minus x bar, yi minus y bar. Now we need to find the square deviation. So let's calculate. This is xi minus x bar whole square. Now we have yi minus y bar whole square. So if you square these if you take the square of the deviation, you will get. So we need to take the sum of all the square deviation. So we will take the sum of the square deviation. So this is equal to 69066.9, and this is equal to 28090. Now let's calculate the sample mean. Let's calculate the standard deviation of the marks obtained by students in their class 10th and in their class 12th. So S of x is equal to 69066.9 divided by 10 under root, that is equal to approximately equal to 83.10, and S of y will be equal to under root of 28090 divided by 10, that is 53. So we have our standard deviation of marks obtained by students in their class 10th and standard deviation of marks obtained by students in their class 12th. So we have S of x is 83.10 and S of y is 53. Now let's calculate the covariance in order to find the correlation coefficient. So let's add a one more column here, that is xi minus x bar into yi minus y bar. So we'll just take the product of these two columns. So this is x. Now how do you find the covariance? So the formula for covariance, as we know, this is sum over xi minus x bar into yi minus y bar, I varying from 1 to 10 divided by 10. So now we need to take the sum of all those product of deviation. So let's add up all these numbers and we will get 28724. So let's write it here. This is 28724 divided by 10. That is nothing but 2872.4. So this is our covariance between the two variables x and y, where x denotes the marks obtained by students in the class 10th and y denotes the marks obtained by students in the class 12th. So we have calculated our standard deviation of the marks obtained by students in class 10th and class 12, which is here, and we have also calculated the covariance between these two variables. Now let's move to correlation coefficient, that is R is equal to covariance of xy, that is 2872.4, and standard deviation of x into standard deviation of y, that is 83.10 into 53. So after calculating we will get 0.652. So this is our correlation coefficient. So this is my correct answer. So 0.652. So this is my correlation coefficient and hence this is my answer, where R is equal to 0.652. So this is the correlation coefficient between the marks obtained by set of 10 students in the class 10 and class 12. So what all we can say from here? We can say that the correlation is positive, that is definite because it is positive in sign, and we cannot say whether it is weak or strong from here. So this is done. Now let's move to our next question. So the question number 3 says, we have given a table which shows the scores of 10 students in their mathematics and statistics exam paper. So this column we have the statistics marks. These are the statistic marks for 10 students, and this is the mathematics mark for 10 students. So we have to find the average score for the statistic exam paper. Let's say x denotes the marks obtained by these two. Let's say x denotes the marks obtained by 10 students in a statistics exam paper, and let y denotes the marks obtained by students in mathematics exam paper. So x takes the values xi, where I is varying from 1 to 10, and y takes the value yi, where I takes the value from 1 to 10. Now this is my first question. Where we have to find out the average score for the statistic exam paper. So what do we have to calculate here? We need to find out the mean of the statistics exam paper. What scores of the mean of the scores that the students obtained in statistics exam paper. So let's calculate the average score. So average score, let's say x bar is equal to 55 plus 87 plus up to so on, it will go till 75 divided by 10. So after adding all those numbers, you will get 696 divided by 10. So this is equal to 969.6. So this is the average score for the statistics exam paper. So this is our answer for this question. Now let's move to the next question. That is the second question. The second question is find the range for the mathematics exam paper. So now we have to find the range of the mathematics exam paper. We know what is the range. What do we mean by range? So what is range? Range, we know it is going to be maximum marks minus minimum marks in the mathematics exam paper. So let's find out what is the maximum mark. So the maximum marks here is 85 and the minimum marks in this case is 60. So this is 85 minus 60, that is nothing but 25. So this is my range for the mathematics exam paper and this is my answer. Let's move to third question. So the third question is, select which of the following describe the correlation between both exam papers. Now we have to find out which of the following describes the correlation between the mathematics exam paper and the statistics exam paper. So in order to do that, we need to find the correlation coefficient. So what is the formula for correlation coefficient? Correlation coefficient R is equal to covariance of xy divided by product of standard deviation of x into standard deviation of y. So let's calculate. So first we'll find standard deviation of x, and this is going to be under root of sum over xi minus x bar whole square divided by 10, where I is varying from 1 to 10. So we need to find the square deviation. Let's calculate. Okay, let's make a table here. Now we need to find the deviation of the statistics exam score from the average score of statistics. So this is going to be, so what was the mean? Our mean was 69.6. So x bar was 69.6. Now we will subtract all those xi from 69.6. 4. Now we need to find the square deviation, that is xi minus x bar whole square. So this is minus 14.6 whole square, which is 213.16. This is going to be 302.76. This is 184.96. This is going to be 416.16. 207.36, 806.56, this is 213.16, 605.16, this is 345.96, and this is 29.16. Now let's calculate the standard deviation of statistic exam scores. So this is going to be, now we need to add up all those square deviation in order to find out the standard deviation. So let's add up all these scores. So this is going to be, if you add all those scores, you will get, if you add all those numbers, you will get 3324.4. So this is 3324.4 divided by 10. That is equal to 18.23. So this is my Sx. What is Sx? Sx is 18.23. Now let's calculate Sy. So for Sy, let's write the formula. So Sy is going to be under root of sum over yi minus y bar whole square, where I is varying from 1 to 10 divided by 10. So we need to find the average score in mathematics exam paper, because y represent the marks obtained by students in mathematics exam paper. So let's calculate the average. So this was our mathematics exam paper. So average score in mathematics is going to be y bar is equal to 85 plus 65 plus 80 plus 60 plus up to so on, it will go to 60 divided by 10. So this is equal to 702 divided by 10, that is 70.2. So let's write it here. So y bar is your 70.2. Now let's find out the deviation of the mathematics exam scores from the mean of the mathematics exam score. So let's calculate the deviation. So this is yi minus y bar. So let's first write yi. So what was the mathematics exam score? So this is 85, 65, 80, this is 60, 70, 63, 76, 68, 75 and 60. Now we need to find the deviation of mathematics exam score from the mean of the mathematics exam score, average score in the mathematics exam score. So this is yi minus y bar. That is, what is your yi? This is 85 minus 70.2. So you will get 14.8. Similarly, 65 minus 70.2, you will get minus 5.2. This is 9.8. This is minus 10.2. This is minus 0.2. This is minus 7.2. This is 5.8. This is minus 2.2, 4.8, and this is minus 10.2. Now let's find out the square deviation. This is minus yi minus y bar whole square. So this is going to be 14.8 whole square, which is 219.04. This is 27.04. 96.04. This is 104.04. 0.04. This is 51.84. This is 33.64. This is 4.84. This is 23.04, and this is 104.04. Right? Now we need to add up the sum of all the square deviation. Let's see, we need to add up the square deviation. So we need to add all these numbers. So we will get 663.6. This is what we will get. Let's calculate the standard deviation for the mathematics exam score. This is going to be under root of 663.6 divided by 10. That is 8.15. So this is done. We have calculated our standard deviation of statistics exam score and standard deviation of mathematics exam score. Now we need to find the correlation coefficient. So in order to find the correlation coefficient, we will first find the covariance. So let's write the formula for covariance. So covariance of xy is sum over product of deviation, that is xi minus x bar into yi minus y bar, where I is varying from 1 to 10 divided by 10. So let's make a separate table here, separate column here. This is going to be xi minus x bar into yi minus y bar. So let's multiply this column and this column. So minus 14.6 into 14.8, this is going to be minus 216.8. This is going to be minus 90.48. This is going to be minus 133.28. This is minus 208.08. This is minus 2.88. This is minus 204.48. This is minus 84.68. This is 54.12 minus 89.28. This is minus 55.08. So let's add up all these numbers. So if you add the numbers in this column, you will get minus 1030.2. So now let's find the covariance. So this is going to be covariance of xy is minus 1030.2 divided by 10, that is going to be minus 103.02. Now what is the correlation coefficient? So the correlation coefficient R is covariance of xy divided by the product of the standard deviation of x into standard deviation of y, where x represents the marks obtained by students in statistics and y represents the marks obtained by students in mathematics. So let's solve it. So the covariance is minus 103.2. What is the standard deviation of statistic exam score? This is 18.23. And what is the standard deviation of mathematics exam score? This is 8.15. So 8.15. After calculation, you will get it as minus 0.69. So your R is minus 0.69. Now let's look at the option. So obviously it is, since R is minus 0.69, it is not positive, so this is wrong. It is negative is correct. There is no correlation, that is not true, because it is minus 0.69, it is not 0, so this is also wrong. But since the value is 0.69, we cannot say whether it is weak or strong, so the only correct option here is negative. So the option is correct. Now let's move to our next section, that is MCQ. So the first question here is, what can be said about the correlation coefficient R of x and y, where y is x square plus 8x plus 16 and x is taking the values of the first 10 positive integers. So we have a equation that is x square plus 8x plus 16 and x is taking the value of first and positive integer, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the y is given to be x square plus 8x plus 16. So as you can see, x is a positive integer, so x square will be positive, 8x will be positive, and if you add 16, that is also going to be positive, and it is definitely going to be greater than x. So if you draw the graph, as x will increase, your y will also increase. This is your x and this is your y. So as x will increase, y will also increase. So it will be in this direction. Now let's look at the option. So definitely our last option is incorrect, because the correlation coefficient is given to be minus 1. That is not correct in this case, because as the x is increasing, y is also increasing. So that is wrong. This is also wrong, because correlation cannot be negative in this case. Now we have two options. So whether R is completely equal, whether R is equal to 1 or whether R lies between 0 to 1. So let's find the value of y. So x square will be 1, 4. So let's calculate x square. So this is 1, 4, 9, 16, 25, 36. This is 49, 64, 81, 100. Similarly 8x, 8, 2, 16, this is going to be 24, 32, 40, 48, 56, 64, 72 and 80. Again, if you add 16, your y is going to be 1. Your y is going to be 25, 36, 49, 64, 81, 100, 121, 144, 169, 196 and 985. So as you can see, for x is equal to 1, your y is 25. So we say it is 1, y is going to be at some 25. It will be here. For 2, y is going to be 36. So there will be a curve. It will not be completely a straight line. It will be something like a curve. It will go in a curve. So for r is equal to 1, all the points should lie on a straight line, which is not happening in this case. So even first option is incorrect. So the correct option here is B, that is r will lie between 0 to 1. So the next question is question number 2 from MCQ, and in question number 2 we have given a table which shows the aggregated performances of 2 Indian captains A and B in ODI cricket. What we mean by disaggregated performance? From disaggregated performance means in home matches and away matches, and aggregated performance we mean both home and away matches. So let's look at the table. So this is the table that is given to us, where so first we will see what do we mean by aggregated data and disaggregated data. So aggregated data is a combination of groups of data into single summary statistics. So what do we mean by aggregated data? So data aggregation actually is a process of gathering data and presenting the data in summarized format. So we have collected here the data from home matches and away matches for Captain A and Captain B, and in this column here we have combined both the data and we have written down the summary for home plus away matches for both the captains. Disaggregated data is the data that is divided into detailed subcategories. So what is disaggregated data? Disaggregated data is the information that you collect from multiple sources or individuals. So in this given data, our disaggregated data is home and away matches. Home and away matches are disaggregated data, and we have combined the disaggregated data to get our aggregated data, that is home plus away matches. And what is Simpson's paradox? So Simpson's paradox is defined as reversal of conclusion in aggregated and disaggregated cross tabulation. Now we'll see what is the first question based on that. So the first question is, based on the data given in table, which captain has the better record in ODI captaincy in terms of win percentage? So we will see. So what we have to find here, we have to find which captain has a better record in terms of winning percentage. So total number of matches played by Captain A is 152 and total number of matches played by Captain B is 260. And total number of matches won by Captain A is 85 and total number of matches won by Captain B is 175. So first we will see for Captain A. So total number of matches played by Captain A is 152 and number of matches won is 85. Therefore, winning percentage is equal to total number of matches won by Captain A in both home and away matches divided by total number of matches played by Captain A into 100. So after solving this, we will get 55.92%. Now we will check for Captain B. So total number of matches played by Captain B is 260 number of matches won is 175. Therefore, winning percentage of Captain B is total number of matches won by Captain B in home plus away matches, that is in ODI cricket, divided by total number of matches played by Captain B into 100, that is equal to 67.30%. So, if we look at the percentage, winning percentage of Captain A, that is 55.92, and winning percentage of Captain B is 67.32. So, the correct answer will be B option, that is Captain B. Captain B has a better record in ODI captaincy in terms of winning percentage. Now, the next question is, second question is, which captain has the highest loss percentage in ODI cricket among the two? So, we will see how many matches are Captain A has lost, that is 66, and number of matches lost by Captain B is 85. So, number of matches lost by Captain A is 66 and number of matches lost by Captain B is 85. Therefore, loss percentage in ODI cricket by Captain A is total number of matches lost by Captain A in ODI cricket, that is 66, divided by total number of matches played by Captain A in ODI cricket into 100, that is equal to 43.42%. Now, loss percentage in ODI cricket of Captain B is total number of matches lost by Captain B, that is 85, divided by number of matches played by Captain B is 260 into 100, that is equal to 32.69%. So, as we can see, the loss percentage in ODI cricket by Captain A is 43.42%, while for Captain B it is 32.69. So, the highest among two is Captain A. So, our correct answer is A. Now, the third question is, which captain has the best win percentage in home ODI matches? Now, we have to look for home ODI matches. So, how many matches won by Captain A in home matches? So, we'll see the table. In home matches, Captain A has won 9 matches and Captain B has won 150 matches. So, Captain A 9 and Captain B 150. Therefore, the winning percentage for Captain A in home ODI matches is equal to total number of matches won by Captain A in home matches, that is 9, and total number of matches played by Captain A in home ODI, that is, so 9 matches he has won and 1 matches he has lost. So total number of matches played is 10. So 9 by 10 into 100, that is equal to 90%. Now, winning percentage in home ODI by Captain B. So, number of matches won by Captain B in home ODI, you will see, is 150, and number of matches lost by Captain B in home ODI is 50. So, this is number of matches won by Captain B in home ODI divided by total number of matches played by Captain B in home ODI, that is 200 into 100, that is equal to 75%. So, we can see from here that Captain A has the best winning percentage in home ODI matches. So, our first option is correct.
So this was the table that was given to us. So the fourth question says, it says which captain has the best win percentage in away ODI matches. So now we have to check which captain has the best win percentage in away matches. So we'll look at this column, away column, and we will calculate the best win percentage. Now let's first calculate for Captain A. So number of matches won by Captain A is, number of matches won is 76, and number of matches won by Captain B, this is Captain B, number of matches won is 25, and total number of matches played by Captain A in away ODI matches is, total number of matches played by Captain A in away ODI matches is 76 plus 1 plus 65, that is 142, and number of matches played by Captain B in away ODI matches is 25 plus 0 plus 35, 25 plus 0 plus 35, that is equal to 60. Now let's calculate the winning percentage of Captain A, winning percentage of Captain A in away ODI matches is equal to number of matches won by Captain A, that is 76, and number of matches played by Captain A, that is 142 into 100. So this will turn out to be 53.52%. Now calculate the winning percentage of Captain B in away ODI matches. So number of matches won by Captain B is 25. Number of matches played by Captain A is 60 into 100. So this will be equal to 41.66%. So as we can see from here that Captain A has the best winning percentage in away ODI matches. So our correct option will be A. So the next part is, does the above data illustrate Simpson's paradox? So let's see. First we will look for the winning percentage. So this is home, away, and home plus away matches for Captain A and for Captain B. So winning percentage of Captain A in home matches. So total number of matches won by Captain A in home is 9. So this is 9 by total number of matches played is 9 by 10 into 100. That is 90%. Similarly, for away matches, winning percentage of Captain A is 53.52% and total is 55.92%. For Captain B, the winning percentage of in home ODI cricket is 75%. In away ODI cricket, it's 41.66%, and in home plus away ODI cricket, winning percentage for Captain B is 63.70%. Let's see the draw percentage. Captain A, for Captain B, this is your home, away, and this is home plus away. Draw percentage of Captain A in whom ODI matches is. So total number of matches draw. So this is 0. So 0 divided by 10. 0 divided by 10, that is 0%. In away ODI matches, its number of matches drawn is 1. So 1 divided by 142, because total number of matches is 142. This is going to be 0.007%. Similarly, for home plus away matches, it's 0.006%. While for Captain B in home matches is 0, number of matches drawn in away matches is 0, and in both 0. So all this is going to be 0%, 0%, and 0%. Now let's look at the loss percentage. A, B, this is home, away, and home plus away. 10%. In away ODI matches, it's 45.77%, and in home plus away, it's 42.76%. While for Captain B, the loss percentage is 25% in home matches and 58.33% in away matches and 32.69% in home plus away ODI. So let's see whether this illustrates a Simpson's paradox or not. So what is Simpson's paradox? Simpson's paradox is the reversal of conclusion in aggregated and disaggregated data. So our aggregated data in this case is home plus away, and disaggregated data is home and away. Now let's look at this table. So you can see that the winning percentage of Captain A is more in both home and away matches as compared to Captain B. But when you look at the home plus away matches, the winning percentage of Captain B appears to be more. So yes, there is a reversal of conclusion in aggregated and disaggregated data in winning percent. So option C will be correct. Now let's look at the draw percentage. So we cannot conclude anything from draw percentage, whether it illustrates a Simpson's paradox or not, because for Captain A and Captain B in both home and ODI matches it's 0%. In away ODI cricket, draw percentage for Captain A is more than Captain B, while in both home plus away matches, again the draw percentage appears to be more for Captain A. So we cannot say in this case that there is a reversal of conclusion in aggregated and disaggregated data. So this option B will not be correct. Let's look at the loss percentage. Again for Captain A, the loss percentage is less as compared to Captain B in both home and away matches. While if you look at home plus away, like this aggregated data, the loss percentage for Captain A appears to be more than loss percentage for Captain B. So again, there is a reversal of conclusion in aggregated and disaggregated data. So option D will also be correct. So the first option says no, because the conclusion in aggregated and disaggregated cross tabulations are the same. So this is wrong. So our correct option is C and D.
Moving to our next question, that is question number 3 from MCQ. The question says, a child has a large number of relatives who have different incomes and expenditures. In order to find out if there is any relation between the income and expenditure of some of his relatives, he collects the data in the table. So Ajay has collected the data from 7 of his relatives to find out if there is any relationship between their income and expenditure. So these are list of 10 of the relatives. Income is given in this table and we have expenditure here. So let's move to the first question, that is, what is the sample mean and sample standard deviation of income of relatives of Ajay? First, let's denote the income of relatives of Ajay by Xi and expenditure of relatives of Ajay by Yi, where I is varying from 1 to 7. We have to calculate sample mean of income of relatives of Ajay. So, sample mean, let it be x bar, that is equal to sum over xi divided by 7, where I is varying from 1 to 7. Let's add up all the incomes. 7, 5, 11, 11, 11, 22, 34, 41, 54 and 68. So the sample mean is 68 divided by 7, that is equal to 9.71. Now we have to calculate sample standard deviation. So what is the sample standard deviation? Sample standard deviation for the income of relatives of Ajay, it's denoted by x bar, that is equal, Sx, that is under root of sum over xi minus x bar whole square, where I is varying from 1 to 7 divided by 7 minus 1, where 7 is the total number of relatives that Ajay has taken into consideration. Now we have to, in order to find the sample standard deviation, we need to find first the deviation of income of relatives of Ajay from the sample mean income. So we know that sample mean, as we have calculated, is x bar is 9.71. So let's find the deviation of each of the income from sample mean income. So this is 6 minus 7.91, that will be equal to minus 3.71 minus 4.71, 1.29, this is 2.29 minus 2.71, 3.29 and 4.29. So this column here represents this deviation of the income of relatives of Ajay from the sample mean income. Now let's find the squared deviation, because we have to find the squared deviation in order to calculate the sample standard deviation. So this is minus 3.71 square, that is equal to 13.676, 22.18, 1.66, 5.24, 7.34, 10.82 and 18.40. Now sum of all those deviations, square deviation. If you calculate, you will get, it will be equal to 79.43. So your sample standard deviation is sum over under root of, sample standard deviation will be equal to under root of 79.43 divided by 7 minus 1, that is 6. That will be equal to 3.638. So let's look at the option. Our sample mean is 9.71. So our first option is incorrect and last option is incorrect. Now we have to choose from option B and option C. So let's look for sample standard deviation, that is 3.638 So third option is incorrect and our correct option will be B. The second question is, what is the sample covariance of income and expenditure from the above data? Now we have to find the sample covariance of income and expenditure. So let's write the formula for sample covariance. Sample covariance, it's denoted by covariance of xy, where x denotes the income of relatives of Ajay and y denotes the expenditure of relatives of Ajay. That is equal to sum over xi minus x bar into yi minus y bar divided by 7 minus 1, where I is varying from 1 to 7. We will first calculate our y bar, that is sample mean expenditure of the relatives of Ajay. This is sample mean expenditure. So y bar is equal to sum over yi divided by 7, where I is varying from 1 to 7. Let's add up all those numbers. These are the expenditure of relatives of Ajay. So 4, 3, 7, 7 for 11, 1, 12, 12 for 16. 1, 4, 4, 8, 8, 7, 15, all add up to 46.6. So the mean sample mean expenditure is 46.6 divided by 7. That will be equal to 6.65. So y bar is equal to 6.65. Let's find the deviation of expenditure of relatives of Ajay from the sample mean expenditure. So 4.4 minus 6.65 will be equal to minus 2.25. This will be minus 2.35. This is 0.75. This is 1.45. 1.65 is minus 1.75 and 2.35. So now we have to find out the product of xi minus x bar and yi minus y bar. So let's write xi minus x bar into yi minus y bar. That is xi minus x bar, so yi minus y bar. Let's multiply 8.3475, 11.0685, this is 0.9675, 3.20, 3.3205, 4.4715, 5.7575, 10.0815. Now we'll add up all those numbers. So after adding, we'll get 44.0145. So the sample covariance, that is COV of xy, that is equal to 44.0145 divided by 6. that will be equal to 7.33. So our correct answer is B. The third question is, what is the unit of correlation coefficient for the given data? So what is the formula for correlation coefficient? Correlation coefficient, that is represented by R, is equal to covariance of xy divided by S of x, S of y. So as we know, the covariance of xy will come in lakh square, and standard deviation will be lakh. Standard deviation is in lakh. So it will have no unit. So what is the unit of correlation coefficient? So the correct option is D. Now fourth part is, what is the value of correlation coefficient between income and expenditure? The formula for correlation coefficient R is, we have already calculated our covariance of xy and S of x. So we need to calculate S of y. So let's calculate S of y first. So S of y is under root of sum over yi minus 5 bar whole square, where I varying from 1 to 7 divided by 7 minus 1. So first let's calculate the square deviation of expenditure from the sample mean expenditure. So this was the deviation of the expenditure of relatives of Ajay from the sample mean expenditure. So the square deviation will be minus 2.25 whole square, that is 5.0625, minus 2.35 whole square is 5.5225, this is 0.5625, 2.1025, 2.7225, 3.0625, 5.5225. Now let's add all those square deviation. So it will be equal to 24.5575. Now let's find the sample standard deviation. That will be equal to under root of 24.5575 divided by 6. That is equal to 2.023. So we have calculated our sample standard deviation of the expenditure of relatives of Ajay. Now let's find the correlation coefficient. So our covariance was, as we have calculated, that was equal to 7.33. Our S of x was 3.638 and S of y we have calculated to be 2.023. So it will be equal to 0.997. This is our correlation coefficient between income and expenditure of relatives of Ajay. So what is the correct option here? This is wrong, this is wrong, this is correct, this is wrong. So C is the correct option. Let's move to our next question, that is question number 4 from MCQ. The question says, let R be the sample correlation coefficient for the data pairs xi, yi, I varying from 1 to n. So we have a data pair, that is xi, yi, and I is varying from 1 to n. And R is given to be the correlation coefficient for this data pairs. Now we have to find out the sample correlation coefficient for the data pair A plus Bxi, C plus Dyi. Now we have another data pair, that is A plus Bxi, C plus Dyi. We have to calculate the correlation coefficient for this set of data pairs. So let the correlation coefficient for the data pairs is R dash, where again I is varying from 1 to n. Let us assume that the sample mean for the data pairs xi, yi be, let sample mean be x bar, y bar, and sample standard deviation to be sx, sy. So in order to find the correlation coefficient, we need the covariance for this data pairs and the sample standard deviation for A plus Bxi and sample standard deviation C plus Dyi. So now we will calculate first the sample mean for A plus Bxi. Let's see. So we will use the properties of mean. So as yi is equal to xi plus c, where I is varying from 1 to n, and you know the sample mean of xi, then sample mean for yi will be equal to, say it to be y bar, that will be equal to x bar plus c. Also, if you multiply a constant from the given data pair, that is c into xi, where I is varying from 1 to n, then the mean sample mean will be y bar is equal to c into x bar, where x bar is the mean for xi. So we will use these two properties in order to calculate the mean and standard deviation for these two pairs of points. You have assumed that the mean for xi is x bar and mean for yi is y bar. So what will be the mean for p of xi? If you multiply a constant, the new mean will be equal to the constant time the mean of xi. Mean of xi, that was x bar. This will be p of x bar. Now what will be the mean for d of yi? As it is given to us, or we have assumed that the mean for yi is y bar, so mean for d of yi will be d times y bar. Similarly, if you add a constant a to b plus xi, the new mean will become a plus mean of pxi, that is b of x bar, and the mean for c of dyi will be equal to the constant c plus d times mean of plus mean of dyi, that is d of y bar, equal to c times s of x. Similarly, if yi was given and you are multiplying a constant, Now let's calculate the sample standard deviation for these data points A plus Pxi and C plus Dyi. So as we had seen in the lectures that if you multiply a constant from the given data points, say if xi was given to you and you multiply a constant, say c, then the new standard deviation will be equal to c times the old standard deviation, that was sx. and adding a constant. If you add a constant to the data point that was given to you, the new standard deviation will not change. It will remain the same. So we will use those two properties to calculate our sample standard deviation for these data point, that is a plus bxi and c plus dyi. Let's calculate it here. So if you multiply the constant p to xi, the new standard deviation will be b times s of x. If you multiply the constant t to yi, the new standard deviation will be d times s phi. Now you are adding a constant to b of xi. So since adding a constant doesn't change the standard deviation, so the new standard deviation will remain the same. That will be b of sx and d of s phi. So this was our data point a plus bxi and c plus dyi. This is our mean. This is our mean. This is our standard deviation, and this is also our standard deviation. Now let's calculate the correlation coefficient. So the correlation coefficient, we have assumed it to be r dash. So let r dash to be equal to sum over covariance of these data points. So that will be equal to xi, where it is b plus bxi minus mean of a plus bxi, that was a plus bx bar, into c plus dyi minus c plus dy bar divided by n, since total number of points was n, where I is varying from 1 to n. Let's calculate this. This is sum over a plus bxi minus a minus bx bar into c plus dyi minus c minus dy bar. So here a and a will cancel out, c and c will cancel out, divided by n, where I is varying from 1 to n. Sorry, it is not n, it is s of a plus bx and s of c plus dy. That was nothing but b of sx into d of s5. This is bt s of x into s of y. So let's calculate this. This is, let's take b as common. So b will come outside, and it is xi minus x bar. From here, let's take d common. Take it here. So this is yi minus y bar divided by bt sx into s5. I is varying from 1 to n, where x bar is the mean for sample mean for xi, y bar was the sample mean for yi, sx was the sample standard deviation for xi, and sy was the sample standard deviation for yi, I varying from 1 to n. So the time, there was one more condition, at p and d are the same sign. So as you can see, in the numerator we have the term p into d, and even in the denominator we have the term b into d. So these two terms will get cancelled out. So whatever the sign of p and d be, it will always be sum over xi minus x bar into yi minus y bar divided by sx into s bar, I varying from 1 to n. That is nothing but the sample correlation coefficient between the data pairs xi comma yi that was given to be r. So the correct answer is C, R.
So this is our question number 5. The question says, let the correlation coefficient R between two variables x and y be 0. Then the variable x and y are. Then how are these two variables related? So let's see what all is given to us. So we are given R is equal to 0. The correlation coefficient between two variables x and y is 0. So we have to decide whether it is linearly related, not linearly related, or equal. So R is equal to 0, and we know that if there is a linear relationship between two variables, then correlation coefficient is not equal to 0. Let's take the contrapositive. Then it will be, if correlation coefficient is positive, that implies there is no linear relationship. So what is given to us? R is 0. So there will be no linear relationship. So this will be correct and this is incorrect. Now we'll see whether these two variables will be equal or not. So let's say these two variables are equal. Let's say x is equal to y. Then in that case, these two variables will be linearly related, and we know that if there is a linear relationship between two variables, then R is not equal to 0. So this will also be wrong. So our correct option is the variables x and y are not linearly related.
Let's move to our next question. That is the last question from MCQ. This is question number 6. So the question number 6 is, consider the set of points. So these are the set of points that is given to us in xy plane. Let's write it here. The points are 2, 6, 3, 8, 4, 10, 5, 14 and 10, n in the xy plane. So when do we have the correlation value to be equal to 1, correlation coefficient value to be equal to 1? The correlation coefficient will be equal to 1 only if there is a linear relationship between these points. Right? It means that all these points should lie on a straight line and it should be positive. Like if x is increasing, y should also increase, and if x is decreasing, y should also decrease. So let's take 2 points from here. Let's take 2, 6 and 3, 8. So in order to get the correlation coefficient to be equal to 1, all the points should lie on a straight line. So let's find an equation for a straight line here. So we have 2 points, say x1 to be 2, x2 to be 3, y1 to be 6 and y2 to be 8. So what is the equation of line? The equation of line will be y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. That is equal to y minus 6 is equal to y2 minus y1, that is 2. x2 minus x1 is 3 minus 2, it is 1, to x minus 2. So this is nothing but y. This is y. So this is y minus 6 is equal to 2x minus 2. That is equal to y is equal to 2x minus 4 plus 6, that is 2x plus 2. So this is the equation of line that we got from these 2 points 2, 6 and 3, 8. That is y is equal to 2x plus 2. Let's see if all the other points satisfy this equation or not. Let's check for 4, 10. So x3 is 4. Let's substitute the value of x here. So y is equal to, let's put x to be 4. So 2 into 4 plus 2, that will be 8 plus 2, that is 10. So it is correct because 10 is given, 10 is the point that was given to us. So it will be on this line, y, that is y is equal to 2x plus 2. Let's check the other point, that is 5, 40. So y is equal to 2 into 5 plus 2. 5 into 2 is 10 plus 2 is 12. So this 12 is not equal to 14. So this point will not lie on this line. So as we can see, there is one point in our set of points which is not falling on this equation, on this linear equation. So the correlation between the x values and y values cannot be equal to 1 since all the points are not on the same line, or all the points are not satisfying this equation. So there is no value for n that can make r to be equal to 1. So the correct option is E.
The first question here is the first question. The question says, if the correlation coefficient R between two variables x and y is negative, then the relation between x and y can be described as. Then how will you describe the relation between x and y? Let's see what is given to us. It is given to us that the correlation coefficient, that is R, is negative. So what is the formula for correlation coefficient? That is covariance of xy divided by s of x, s of y. Now as we know that s of x and s of y is always positive, they are always positive, so the product of them will always be positive. Then so correlation coefficient will be negative only if covariance of xy will be negative. And when will this happen? This will happen xi minus x bar into yi minus y bar will be negative. So this will be negative if both x and y will move in the opposite direction. So let's say this is your x and this is your y. So this will happen in the case of both x and y move in the opposite direction. It means if x increasing, y will decrease. If x increasing, y will decrease, and if y increasing, x will decrease. So in these two cases, our covariance of xy will be negative, and hence the correlation coefficient will be negative. So let's look at our option. When y decreases, x increases. So this is correct. Y decreases, x decreases. This is wrong. Y increases, x decreases will be correct. Y increases, x increases will be wrong. Y increases, x doesn't change. This will also be wrong. Let's see why this is wrong. Let us say this is your x and this is your y. So y is increasing. When y is increasing, x doesn't change. When x won't change, you will get something like this. So x remains constant and y is increasing. So in this case, your product, this xi minus x bar, will be 0 in this case, and hence the covariance of xy will be 0, and hence correlation coefficient will be 0. So this is wrong. So our correct option is C and E. So this is our last question. In this question, we have given a table, and the table represents the IQ score of 8 fathers and their daughters. So this table represents IQ score of 8 fathers and their daughters' IQ. So let us assume that X represents the father's IQ and Y represent their daughter's IQ. Let's say X takes the value Xi, where X is varying from 1 to 8, and let's say Y takes the value Yi, where Y is varying from 1 to 8. So this is our X, this is our Y. Now, so let's see the question. Choose which of the following describe the correlation between the IQs of fathers and their daughters. So now we have to find the correlation between IQs of fathers and their daughters. So how will we do that? In order to find the correlation between IQs of fathers and daughters, we need to find the correlation coefficient. We need to find the correlation coefficient R to determine the correlation between IQs of fathers and daughters. So let's calculate. So what is the formula for correlation coefficient? The formula is R is equal to covariance of xy divided by S of x into S of y. So what is the covariance of xy? This is sum over xi minus x bar into yi minus 5 bar, yi minus 5 bar, I varying from 1 to 8 divided by n, which is 8 in this case. So this is 8 into S of x into S of y. So let's first calculate the standard deviation of father's IQ and standard deviation of the daughter's IQ. So in order to find the standard deviation of father's IQ and the daughter's IQ, we need to find the mean of the father's IQ and mean of the daughter's IQ. So let's calculate the mean first. So these are x's, and in order to find what is the formula for mean, so mean is going to be, let's say x bar represents the mean for father's IQ, that is sum over xi divided by 8, where I is varying from 1 to 8, and let y bar represents the mean of daughter's IQ, where y bar is equal to sum over yi, I is varying from 1 to 8 divided by 8. So let's calculate the mean. So we need to add up all those IQs. So this is going to be 903. And when you add the daughter's IQ, you will get 864. So what is x bar? X bar is going to be 903 divided by 8. That is 112.875. And y bar is going to be 108. This is your x bar and this is your y bar. Now, in order to find the standard deviation, we need to find the deviation of the father's IQ from the mean IQ and the deviation of the daughter's IQ from their mean IQ. So let's calculate. So x bar is 112.875 and y bar is equal to 108. This is your x. Let's say let's calculate the deviation. So xi minus x bar. So this is going to be 130 minus 112.875. So this is 17.125. This is going to be 100 minus 112.875. That is minus 12.875. This is going to be 11.125. This is going to be minus 23.875. This is going to be 19. Now let's calculate the deviation of father's IQ from the mean IQ. So this is going to be 130 minus 112.875. This is 17.125. This is going to be 100 minus 112.875. That is minus 12.875. This is going to be 11.125. This is going to be minus 23.875. This is going to be 19.125. This is going to be minus 13.875. This is going to be minus 12.875. This is going to be 16.125. Now let's calculate the deviation of daughter's IQ from the mean IQ. So this is yi minus y bar. So y bar is 108. So 108 minus 108 is 0. Now 117 minus 108 is going to be 9. This is going to be 4. This is 7. This is minus 8, minus 6, minus 33 and 27. Now calculate the square deviation. So this is xi minus x bar whole square. That is going to be 293.265. This is 165.765. This is 123.765. This is 570.015. This is 365.765. This is 192.515. This is 165.765. This is 260.015. Now let's calculate the square deviation of y. So this is 5i minus 5 bar whole square. This is 0 square is 0, 9 square 81, 4 square 16, this is 49, this is 64, this is 36, this is 1089, this is going to be 729. Now in order to find the standard deviation, let's try the formula for standard deviation. So S of x is going to be sum over xi minus x bar whole square, where I is varying from 1 to 8 divided by 8. So this is going to be under root of. Now let's find the sum of the square deviation of x. So let's add all those numbers, and this is going to be 2. This is going to be 2136.87. And let's add up the square division of y. This is going to be 2064. So standard deviation of x is going to be under root of 2136.87 divided by 8. That is 16.34. And standard deviation of y, S of y, is going to be under root of sum over 5i minus 5 bar whole square, I varying from 1 to 8 divided by 8. That is 2064 divided by 8. And this is equal to 16.06. So as you can see that the deviation for the father's IQ and the daughter's IQ are nearly very same. Now we need to find the covariance of xy in order to calculate the correlation coefficient. So let's make the table quickly. So this is our xi minus x bar. So in order to find the deviation, like in order to find the covariance, we need to find the product of deviation. So I will write the column of xi minus x bar, yi minus 5 bar quickly, and then we will calculate. This is xi minus x bar, this is yi minus 5 bar. So in order to find the covariance, we need to find the product of deviation. So let's quickly write the columns xi minus x bar and yi minus y bar. So xi minus x bar, yi minus y bar, and their product, that is xi minus x bar and yi minus y bar. 7. Now let's find the product. So this is your 0. This is going to be minus 115.875. This is 44.5. This is minus 167.125. This is minus 153. This is going to be 83.25. This is 424.875. This is 435.375. Now let's calculate the covariance. So covariance of xy is sum over xi minus x bar, yi minus y bar product, I varying from 1 to 8 divided by 8. So let's sum up all those numbers. You will get 552. So this is covariance is going to be 552 divided by 8. Now what is the value of correlation coefficient? So the correlation coefficient R is going to be covariance of xy divided by product of standard deviation of x and standard deviation of y. That is 552 divided by 8 into S of x. What is S of x? S of x is 16.34. So this is 16.34, and S of y is 16.06. This is 16.06. So after calculation, you will get R is equal to 0.26. So the value of correlation coefficient is 0.26. Let's look at the option. So R you got is 0.26. So this is definitely not negative, so this is wrong. Positive, this is correct. No correlation, that is also incorrect because R is not equal to 0. This is weak because it is very close to 0. So 0 point, this is going to be weak, and this is definitely not strong. So this is also wrong. So our correct option is B and D.